Hello everyone, we are Team Aurora Borealis, and today we are going to be presenting our study, the Plebeian algorithm, a democratic approach to censorship and moderation. What's the issue and the main background behind our project? Well, it's really well known that social media can propagate the spread of misinformation, especially through echo chambers and virtual person-to-person interactions. This large-scale spread of misinformation is classified as an infodemic. Algorithms determine the content which is allowed to spread, and so analyzing these algorithms and their techniques is the main strategy to curb infodemics on social media platforms. Status quo algorithms are moderate at COVID-19 misinformation. However, they're not effective at preventing future infodemics. So what are the main implications of our research? Well, the spread of misinformation happens on both sides of most issues, and this can really intensify the effects of a pandemic and pronounce real-world side effects. This includes viral transmission, discrimination, and even to the extent of rioting. In times of crisis like these, correct information may be the key to saving lives. Preventing misinformation propagation on social media prevents the propagation in real world. At the same time, it is critical to ensure that personal freedoms and freedom of expression are maintained throughout the process. So what's the main objective and research question for a project? What is the optimal social media algorithm for the reduction of the spread of infodemics?
Right. Moving on to our methodology of the paper, we looked at various sources from various social media platforms for our information, and then continued on to clean up the data and analyze it through a sentiment analyzer and visualize it. So to first start off with, in terms of gathering information, we use several APIs. TorquePy, which was used for gathering Twitter data, URL-lib3, which was used for Reddit data, and also another one known as Basque Pi 4chan, which was used for gathering 4chan posts. These were the three major APIs that we managed to gather data from. However, we also used data sets for Facebook, Twitter, Parler, and YouTube to further bulk out our paper and to add more to the paper, as well as to ensure we had other sources to corroborate our claims for. Moving on to actually how we went about cleaning and analyzing our data, we started with putting all the data into a pandas data frame and then using things such as regex, demoji, Beautiful Soup 4 or BS4, and PyEnchant to remove things that would cause the data analyzer to glitch, things such as white space or removing languages that weren't English, as well as translating emojis into text. From there, we used a sentiment analyzer to actually analyze the data. We started by using Vader, or an analyzer started by using Vader, also known as a valence-aware dictionary and sentiment reasoner. And from there, NLTK, also known as Natural Language Toolkit, was able to utilize this dictionary to determine whether or not words in a post were negative in emotion or sentiment or positive. And from there, SymPy was able to calculate the specific numbers related to these sentiments. Finally, we managed to use things such as Matplotlib, Seaborn, and NumPy to create histograms, violin plots, and KDEs using linspace.
So we will now be moving on to the demo. I do have to apologize because I'm currently running recording software in the background, so there's quite a bit of a delay in using our software, but typically what I'm doing will happen in a matter of like a second, less than a second. So I'm going to put in a first so we're going to be doing a demonstration of the flag phase. So essentially you can put in text and it will tell you whether or not that text would get flagged. So a good positive sentiment example that we could do that would be promoting true information would be wear masks, to save lives. If I hit submit, and apologies again because it does take a second, it comes back as false. It'll show you your positivity score down below. So false means that the flag would not be set and it would resume as normal. I'm just going to run the program here again for you. So here is the back to where we were initially. If I type in, for example, the 2020 election was rigged, obviously misinformation. If I press submit and give it a second, it says true. So it tells that this information, the result indicates that the post may contain misinformation, and as such it would proceed on to the next phase, the jury phase. Okay. So now I'd like to talk a little bit about the model analysis. So I'm going to talk about the scope and the robustness of our algorithm. So the scope of the algorithm is very wide. It can be used on a bunch of different types of social media. We specifically analyze textual social media, but it can also be done for visual social media and oral social media. So it could be expanded very easily. The Plebeian algorithm must be implemented with high regard to the specifics of the existing algorithm and community on a case-by-case basis. So it should really be adapted to the specific situation and to the algorithm that's already in place. It should be integrated deeply within that algorithm and within that community. It's effective not only at reducing the spread of infodemics, but it's also effective at infodemiological prevention. So it helps to make sure that future infodemics just don't even get started. They don't take off. It assists in the promotion of true information, regardless of political affiliation, which is very important. Both sides of the political aisle can get behind it. So it doesn't specifically take a single worldview or a single perspective as higher than another. The algorithm is very fluid, and it will naturally evolve as new truths are uncovered. So it's important to note that truth is constantly evolving. It's essentially what the truth is determined by in our algorithm is by what the popular opinion of the truth is by the general population using the app. So as new science is uncovered, as new scientific research is done, the algorithm will naturally evolve to encompass those truths as they become more common knowledge and commonplace.
Human beings are like that. We want to live by each other's happiness, not by each other's misery. You, the people, have the power to make this life free and beautiful, to make this life a wonderful adventure. Let us fight for a world of reason, a world where science and progress will lead to all men's happiness. Soldiers, in the name of democracy, let us all unite. This was a quote from Charlie Chaplin in 1940, and the reason why we conclude our presentation with this beautiful quote, because we really think it really embodies the main principle of the Plebeian algorithm, that human beings are very, very much people that will make these kinds of generally somewhat rational decisions if they are given the chance. And this is what we're trying to do by creating this democracy that upholds freedoms and this expression of speech and liberties. We really do think, and it's been backed by some of our research, that this will be a fantastic way at combating against the kind of misinformation infodemics that we have seen in recent history.
Now, we extend a heartfelt thank you to the Big Data Challenge for offering this opportunity to present our ideas to industry and academic experts. Through this project, we were able to investigate how people search and navigate the internet for health-related information, as well as how we communicate and how people share this. And by collecting, analyzing data, we were taught to critically consider the validity of health claims within media and establish objectivity in our analysis. Through this, we could suggest the solution, the Plebeian algorithm, and identify the types of viral health misinformation patterns. We thank the sponsors, and we look forward to fielding any questions you may have on Big Data Day. If you have any questions, please send us an email or visit the website for the flag face demo and jury phase demo.